Hi, so I want to make a video here talking about LCD repair, which there's quite a number of on YouTube already, but I want to make something a little bit more specific to these Pelco monitors, these PMCL series monitors, particularly because there's a lot of them floating around on eBay, and you can get them for next to nothing. And they're actually fairly decent monitors in that they have been, or supposedly designed to run 24/7 in a security surveillance room sort of application. I have two of them set up here, 19 inches. One is a full screen view, if you will, of whatever camera I want to look at. The other one is the split screens, but I have it showing just a PC right now. So I have one pulled apart here, which I'm in the process of resurrecting. Now, I've come across the same problem on 3 of these monitors. I don't know how long they were in service before I got my hands on them, but I'll show you one of the most common failure modes that I have personally dealt with, and that is in respect to the LCD inverter, which resides right here. The way the modeling works on these is you have their PMCL and then 2, 3, 4 something. So the 200, 300, and 400 series, obviously the higher the number, the more options they have in that they come with, you have for some reason 12 volt in and out, VGA, DVI, multiple BNC inputs, as video, a USB hub for some reason, and whatnot. So the 400 series is really, the highest SRT supercharged model, if you will. Whereas these ones here, you can see it just has BNC input and VGA. Now, upon opening this, we are going to simply use our powers of observation here. No specialty diagnostic equipment of any sort. And you can really diagnose and repair a multitude of problems simply by looking at stuff. Now, I'm going to put this here on the tripod and get a bit of a closer view. To remove it, there's a bunch of screws around here, not very complicated. You do have to remove these nuts here from the video connectors, as well as 2 screws from the power connectors, and the whole thing just comes off. And we should actually probably unplug this to relieve some strain from that, because that's not a good thing. And the first thing I'm going to take out is the LCD inverter. Now, it's generally a wise practice to let these things sit for a while and let any capacitors discharge before sticking your fingers around in here. And while you're diagnosing something, you should not have it plugged in. That's a fantastic way to get a nasty shock, particularly from the high voltage inverter. So this comes apart with one connector here, and then the connectors for the lamps on either end. You want to be careful that you don't damage these connectors. Then we can take out the LCD inverter, and I'll show you the problem that I've had with at least 3 of these. Now, these are off-the-shelf components already manufactured by VH Tech, and Googling this model number over here revealed that. This one here is a version 0.02. The other 2 monitors that I showed you actually have a version 1 point something else, so slightly revised version and a different model number. I'll drop that in the description as well. Now, I had to change this capacitor once because it ruptured, and that's again going back to my main point, which is what can you see on the board? Where is the shit stain? Where has the smoke been let out? And in that case, it was the capacitor. We've all seen electrolytics that have let the smoke out. Sometimes it's not obvious, but generally, and especially on these ones that have perforations on the top to kind of let them explode versus, popping quite dramatically, you can see it. It'll either be buckled or it'll have totally let out completely. So that was one thing that I had to do. Now, the other thing I've noticed is right here, there is a surface mount transistor that we can see. There's the shit stain. Now, I don't know if it'll quite show in this light, but we can see there's quite a bit of yellowing to the board, indicating severe heat. Once we've determined that, we have to identify the component that we're looking at. Electrolytic capacitors, it's not entirely complicated at all. It's written right on the side, the value and the voltage. In this case, we have a 25 volts at 100 microfarads. You can go up slightly in voltage, but you want the the microfarads to be, or the capacitance to be within specification. This transistor over here doesn't tell us a whole lot. The only thing that we can see on it is dk and qm. Now on the other one that I took apart, it said dk and qs. So how do we identify these types of SMD components? Well, I'll show you in a minute. The other thing that we want to look at is the power supply itself. I didn't have any problems with the power supply, so I left it in, but that's this thing over here. You can see that the high voltage comes in and plugs directly into it, and then this supplies power to everything else on the board. In generally most LCD monitors, there's just one big giant board. Sometimes you'll have a separate T-con board, but generally you'll have one big power supply and the LCD inverter will be with that. My thinking here is that they're trying to save costs on components by picking these pre-existing components and jamming them all together to build their product. The other reason could be by having this thing slightly separate, you're saving the components from excessive heat buildup. So I found this website here. It's called smanuals.com. We're going to go over here where it says marking SMD, and I'll just hit Control F and search for DK, which was the first two letters that I saw on my component. And you can see here it lists all of the possible packages and device model numbers that it could be, and up here we can see that it's an SOT89 package, and that looks quite a bit like what we're dealing with. And we can see it's manufactured here by Hitachi and Kexin and whatnot. Now I'll try searching for the other letters, which were, what was it, QS on the other one. That was the one that revealed some similar results. You can see again it's an SOT89 package. This one is by NEC, and we can even see the data sheet for it, which will give us a bunch of values as to what exactly we're looking for. So once again, simply by using powers of observation, we can determine what the problem is and then go about fixing it. Simply by looking at what we have, seeing where the damage to the component is, identifying the model number or the value of the component, and then going about replacing that. The other thing that you can do is try and find the entire component itself. Like I said, I put in this number in Google, and sure enough I found you can buy this whole piece for about $20 or $30 depending on the source. So that's pretty much it for these Pelco monitors. If you have any more information about these or you have any questions, leave a comment.